Hello, the problem reads, starting from rest at position equal to 0, a boat travels in a straight line with the acceleration shown by the acceleration position graph. Determine the boat's speed when position is 50 feet, 100 feet, and 150 feet. The second problem reads, I'll just read the last part, construct the velocity position graph. Both these problems are coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. So we are dealing with rectilinear motion. This is motion in a straight line or straight path. Right, so let me just remind ourselves of the three basic kinematic equations. We have velocity, which is the time derivative of position. We have acceleration, which is the time derivative of velocity, and when we make dt for both equation subject to the formula and then you equate it, then we have one derived equation, which is a ds v dv. Right, let me just show the coordinates for this. This is 0,8. I will need to use them later on to develop the equations for these two intervals, and this one is a 100,6, right, and this one is 150,0, right. So let's find the equations for the interval 0 to 100 and 100 to 115. So we have, sorry, this is s and not t. So this is from 0 to 100 feet, right? This is feet. So again, we want to use the equation. Remember this equation, y is equal to mx plus c, where m is the gradient change in y divided by change in x, and c is the intercept. So use this. So instead of y, our cells will have acceleration, and instead of x, we'll have the position. Okay. So let's employ this equation to develop the equations. Let's start with the interval 0 to 100. So we have a equal to ms plus c, right, and therefore our a is just going to be equal to, so let's find I'm going to, so alright, so I'll have a m here is the gradient, so I'll say 8 minus 6 divided by 0 minus 100, then times s, then plus c. Then I'm going to use one coordinate to find c. I'll use 0,8. So I'll say here I will have 8 equal to this is a 2 divided by minus 100, then times 0 plus c. Therefore our c is 8, and this equation is just going to be equal to 2 into 100. That's a 0. What? This is a minus 0.02 plus 8. Therefore this line is a is equal to minus 0.02 plus 8. Let's work on the other interval, which is from s. We have, when we are moving from 100 to 150 feet. Then in this interval we have our a equal to change in y which is going to be equal to 6 minus 0 divided by 6 minus 0, then in the x we have 100 minus 150, right, by s, then plus c. I'll use the coordinate 150, 0, so I'll have 0 there. This is 6 divided by 50 minus, then I have 150 there, right, then plus c. Therefore my c here is just going to be equal to, if we calculated this, we have minus 6 divided by 50 by 150. This is equal to 18. Alright, therefore our acceleration is just going to be equal to minus 0.12 s plus 18. Okay, so this equation is governed by this particular, this line, this interval, minus 0.12 s plus 18. Right, so what else? Once we have this, then we can now start working on let me just create a boundary for this. Okay, something like so. So let's start working. So let's go to case, let's say case 1, 12-56. Right. What do we have? 12-56, of course. We need to find the equation for velocity. Okay, so what we'll do is I'm going to use this equation, this one, right? So I'll say A ds is equal to V dv, and I'm integrating for s from 0 to s, and then this one from v naught to v. My acceleration, I'm dealing with acceleration in the first interval, which is from t 0, this is not t, it's s, so I'm starting with the interval from 0 to 100 feet. Therefore this is going to be equal to, I will have from 0 to s, right, from 0 to s, and then my acceleration here is so let me go maybe on top there. I just collect this as well. Okay, let's bring it here. Right, so here, like we said, from s0 to 100 feet, we have acceleration equal to minus 0.02 s. Sorry, here I forgot an s, and also here there is an s. What happened? So this is, there is an s there plus 8. There is an s there plus 8. Okay, sorry about that. An s plus 8. So we are going to fit this in our equation. We'll feed this. Right. So at this point, we're going to have as 0 from 0 to s. A is just a minus 0.02s plus 8 ds equal to 0 to v dv. Okay, therefore we have 0.02 s squared divided by 2 plus 8s equal to v squared divided by 2. Therefore our v is just going to be equal to minus 0.02 s squared plus 16s and everything in a square root. So now let's find the values of s at 50 and 100. So v at s equal to 50, let's plug in that value there. So we have minus 0.2 by 50 squared plus 16 by 50, square root of that. We have a 27.39 meters, no, not meters, feet per second, right? Square root of 750, 27.39 feet per second. Then v 800, this is equal to minus 0.02 by 100 squared plus 16 by 100. Then square root of that, we have a 37.42. Okay, that's at the boundary. So we are going to check if in the other equation in the next interval. So let's go to case not case 2. We are within the same interval, the second interval, which is from 100 to 150 feet. In this interval, our a is equal to minus 0.1 s plus 18. So we'll feed it directly in our equation there. We'll have our initial boundary condition here. It will be that is, we are starting from 100, and at 100 we are starting from 100, so we'll say 100 feet from 100 to s, and then our a is minus 0.12 s plus 18 ds equal to, and then for v naught at 100 feet, we found a 37.42 to v, then v dv, right? Therefore just 1 minute. Therefore, writing this, we'll have 0.12 s squared divided by 2 plus 18s, and then minus 0.12 by 100 squared divided by 2, and then we have a plus 18 by 100, then we close this, then we say equals v squared divided by 2 minus 37.42 squared divided by 2. Okay, is it visible enough? Yes, it is. Maybe I move it like so. Just move this like so. Right, and do something like so. This is divided by 2, right? Okay, therefore let me move this as far as there. Therefore, what happened? So we said this squared over 2 plus, then we have minus this squared, okay, and then plus this, then this over 2. This is fine, right? Okay, and then this one here, this is 0.12 like so, minus. Alright, so we have b equal to minus 0.12 s squared plus 36s. Let's work out on the other one. So it's 0.12 by 100 squared divided by 2. Then minus 18 by 100. Okay. Then plus 37.42 squared divided by 2. Then by 2. So this becomes a minus 999.74, and everything is in a square root. Right, let's check it. S equal to 100. That's a boundary there. Supposed to get a similar value. So minus 0.12 by 100 squared plus 36 by 100 minus 99.74. Square root of this, we have a 37.42 feet per second. Then at v equal to 150, remember these values here. Okay, let's fit them in that equation. So minus 0.1 by 150 squared plus 36 by 150 minus 99.74. Okay, square root of that, we have a 41.23 feet per second. Let me check it again. Minus 0.1 by 150 squared plus 36 by 150 minus 99.74. Square root of that, 41.23. Alright, so we have found the values of the speed at 50, 100 and 150. So let's now plot the velocity position graph. Right, so let's say we have something like this. We start plotting from here, something like that. Okay, so let's say this value here is 100, this one here it is 100, and here it is 150. Of course, this is time in seconds, and this is velocity. Sorry, that's not time. This is position in feet, and then this is velocity in feet per second, right? All right, so which equations are these? We have two equations. In the interval, we have in the interval s from 0 to 100 feet, we do have one equation, which is this one here. Where is it? V is equal to square root of minus 0.02 s squared plus 16s. Okay, and then in the interval 100 to 150 feet, we have V equal to square root of minus 0.12 s squared plus 36 s minus 999.74. Okay, so these two equations are the ones we are using. So at 0, let's the first interval. At 0 here, we have at s equal to 0, where are we? Here. All right, there we go. So at s equal to 0, as velocity is 0, and then at 100, we found the value at 100. It was why is it at 100 is 37, and this one is it is a root, right? So we are saying this one is going to be equal to this one will be something like so. We're going to have something like this, right? Let's say something like so. Up to 100, we have 37, and then in the interval, in the second interval, is also a root, so it will continue in this same manner. Let's say it goes on up to 40, maybe up to somewhere there. Okay, so let's just show these particular points here. Let's show them. So here we have this point like so, and we do have another point like so. Okay, there we go. Right, so those are the points, and this point here is a 37. This one is a 37.42, and this one is a 41.23. Okay, let's also give the title for this one. This one is case 2, which is a 12-57, right? Okay, I guess we are done. So we have found the speeds at 50, 100, and 150, and then what else? We also had to draw the velocity position graph. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye. and see you in my next screencast.